Good morning, students. Am I audible? Am I audible?
Yes, sir.
Yes, sir.
Okay, fine. How was the question paper for the internal? I hope it was very easy. Yes. How was the internal paper? Any one of you can let me know. Any one of you unmute yourself and tell me how was the question paper? Was the question paper easy? Have you answered all the questions? I think everything that was given was on the notes itself, is it not? Yes. Okay. So we shall continue our discussion today, and we shall try to finish off the sedimentary rocks today. Okay. So that from tomorrow or the next from tomorrow, I'm going to continue my class on the metamorphic rocks. And tomorrow, as I got some works, I have got some other work, so I'll be engaging class at 2 o'clock or 3 o'clock in the afternoon. I'll send you the link, and you please join by that time. Tomorrow 10:15, I will not be able to take the class at 10:15, so I'll take the class at 3 o'clock in the afternoon. So I'll send the link. You people join. Okay. So today we shall continue our discussion on the next rock, that is the shale. So you know that shale is a continuation of a sedimentary rock that is formed by the compaction of the silt and the clay size material. Okay, you know what is a silt? Okay, silt is a one particle which is often found due to the running water. You can see the fine grained mud that is being found all along the roadside whenever there is a huge storm. Okay, when there is a huge rainfall, you can see yesterday there was a huge rainfall. So if you go beside a slopy road or any place, you can see fine grained soil that will present at the outskirts of the roads. Okay, such particles are usually called as silt. Okay, so the combination of silt and clay sized material, okay, which we commonly call as mud, will be formed to form a shale rock. Okay, so it is this composition which makes the shale into a category of a sedimentary rocks which are called as a mudstones. So as these are commonly composed of mud sized particles and mud particles, these shale rocks are often called as a mudstones. Okay, so sometimes what happens is these mudstones will be fissile, which means to say it will be formed in the form of layers one above the other. Okay, so they may be laminated also. So laminated means it will be made up of thin layers which are easily breakable, and also fissile means it is one wherein the rock can be split into thin pieces. Okay, so lamination means it is made up of one above the other. The layers are made up of one above the other layers. Fissile means if the rock readily splits into two pieces along that laminations, only along that laminations, if it can be broken into two pieces. Okay, it can, if the layers can be removed very easily. Okay, so then such ones are called as a fissile rocks. So coming to the composition, yes, composition, it is mainly composed of clay sized mineral grains. So the grains are very tiny in particles. Okay, they are the clay minerals which has other minerals like the elite, kyolinite and the smectite. So these are the three minerals which are oftenly found in the shale group of rocks. So other particles also includes the quartz, which is the chert, and also the feldspars. Okay, so it may also contain some of the organic particles also along with them. Okay, light constituents of the carbonate minerals, iron oxide minerals, the sulfide minerals, and also the heavy mineral grains. So the other constituents which are present in the shale rock are determined by the environment of deposition of the shale rock. Okay, so which environment the rock has been deposited determines the other constituents. Like if it is deposited in an organic environment, then it comprises of the organic particles. If it is deposited in a carbonate environment, that is limestone, dolomite bearing rocks, then there may be some addition of the carbonate minerals. If it is mainly deposited in the iron oxidizing environment or the reducing environment, it contains some iron oxide minerals. If it is deposited in the sulfide bearing SO4 bearing environment, it contains some sulfide minerals. And if it is deposited in heavy mineral grains, then it is also attributed to the composition of the shale rock. And also the other constituent itself determines the color of the rock also. Now for example, if the shale rock is being deposited in a carbonate environment, then it gives whitish color to the shale rock, whitish to grayish color. And if the shale rock is deposited in an iron group of minerals or iron oxide minerals, then it gives reddish color to the rock. Okay, so coming to the next is the natural oil and natural gas reservoirs. Yes, the conventional oil and natural gas reservoirs are always found under impermeable shale rock itself. The shale rock does not have much of the pores within them. Okay, so the presence of pores is very minimal. The presence of pores is highly minimal. So what happens is, you can see these are the gray colors. These are the gray colors are the impermeable rocks of the shale rock, which acts as a trapped reservoir for the formation of oil and natural gases. Okay, so conventionally, if there is some shale rock present within any underground formation, then what is the first thing they will do is they will always look for oil and natural gas reservoirs itself. It comprises of the oil and natural gas reservoirs. Okay, so what happens is, as the shale rock is highly impermeable, okay, it acts as a barrier for the escape of the oil and natural gases between these units. So that's why it is trapped within two units. Okay, so if it is present in a sandstone, so sandstone contains many pore spaces through which the oil and natural gas reservoir can be escaped, but the shale rock does not possess any of such type, so it will act as a natural barrier or a reef. Okay, so coming to the hydraulic properties of the shale, this is very important. Make note of these hydraulic properties. This will be important as it is having engineering application. Every now and then you can expect this question to be arrived in the question paper. Okay, so what are the hydraulic properties of shale? See, hydraulic properties are the characteristics of a rock, such as the permeability and porosity, that defines or it reflects the ability to hold and transmit the fluids. This is very important. The porosity and permeability are the two important properties that a rock should possess. Okay, only if the water conductivity and movement of water to take place in a rock or water or oil or natural gas, anything like that, it has to conduct through the rock, means the rock should always possess the porosity and permeability within them. If the rock does not possess this porosity and permeability, then the transmission and also the ability to hold the fluids or water or oil or natural gas will be very low. Okay, so what happens is, the shale has a very small size particles. These are very small particle sized, okay, of the order of the mud. You can see the mud is very fine grained in nature. Okay, so this spaces between the arrangement of the minerals are very small. The interstitial spaces are very small. So whenever the interstitial spaces are very small, the ability of the fluids to move through it or pass through it is very low. Henceforth, what happens is the permeability and porosity is very low. That's why oil and natural gas and water has got the difficulty moving through these rocks. You can see Dubai and other places why it has got a lot of the shale reservoirs or the oil and natural gas reservoirs, but it doesn't possess any of the water content means. So Dubai and that goes to the plate tectonics. That means to say the continental drift theory. Okay, so why you don't find water over those places? Because it is mainly made up of shale rock, and in shale rock, the porosity and permeability is very low. The ability to absorb the water and also to transmit the water is very low. That's why you cannot find water every now and then in the parts of Dubai, Abu Dhabi, and Sharjah. Okay, so that's why it has serves as a cap rock for oil and natural reservoirs. Okay, so it is also an aquiclude that blocks the flow of groundwater. See, there are 4 different formations which we'll discuss in the 4th module. Okay, aquifer, aquitard, aquifuge, and aquiclude. Okay, all of them are the water bearing concepts. So one may conduct the water, one may hold the water, one may does not transmit the water, anything like that. Okay, so aquiclude is a one which does not allow the water to pass into it or allow the water to pass out of it. Okay, so that's why as the interstitial spaces are very small in shale rock, it does not allow the shale rock to take significant volume of the water. So that's why this rock can hold the water, gas and oil, but it is not able to transmit them. Okay, it acts as a very good reservoir. Okay, so water can be holded within the shale rock. The water can be held within a shale rock, but the transmission is very low because of its low permeability. So coming to the engineering property, so this is one important thing which is called as expansive soils. Okay, so another 2-3 months ago you might have heard or the news of the Talkaveri, wherein Brahmagiri mountain itself had collapsed. Okay, and it had moved to lot of far distance. That is because of this expansive soil itself. What happens is the Kodagu and other places, it is made up of the shale rock itself. Okay, so during monsoon, what happens is this shale rocks, they have got the ability to absorb the waters and also release large amounts of water. Okay, when there is change in moisture or weather or temperature conditions, what happens is there is severe change in the volume of the rock. Okay, so these materials are also called as the expansive soils. When there is change in weather condition, it absorbs the water, it takes the water and expands. Okay, the soil expands, they swell, and when the temperature is very hot, it dries off and it shrinks. Okay, so whenever this property is being present in the soil, such property is called as expansive soil, wherein the soil absorbs the moisture and expands and they swell, and when they dry, they shrink out. So if this is present this is present much in a shale rock, and if that shale rock is present in any area, then buildings, roads, the utility lines and other structures, when they are placed upon them or when they are built with such material, so they tend to weak or damage the forces, and also they may cause damage to the structures. That's why whenever you are going to propose any structure on shale rock, you have to be very double careful because of this expansive property of the shale rock. It's only the shale rock that has got this expansive property. So coming to the slope stability, yes, shale is also a rock which is associated with landslides. Okay, now the Konkan railways, the tunnels between the Ghati Subramanya, the Kuke Subramanya, the Dharmasthala and other places, where if you go towards your railway line, the Konkan railways, every now and then in the monsoon you can hear the news of the landslides. That is because of the presence of the utmost abundant shale rock as a rock type. Okay, so what happens is, due to weathering, it transforms the shale into a clay rich soil, so which has got a low shear strength, so it has got a rapid movement down the slope. Okay, and also overloading and also the excavation by humans which also caused the failure of the shale rocks. Okay, so this is a very good example of the shale rocks. So coming to the next rock is a conglomerate. So conglomerate is a clastic sediment rock that is formed by the rock fragments which contains larger, greater sizes of the particles which are more than 2 mm in diameter and are rounded in fragments. So the space between the two fragments is generally filled with the small particles, or it may be filled with the some calcite or chert or the quartz, which binds the rock together as a cementing material. Coming to the composition of the conglomerate, conglomerate has got a lot of variety of the compositions. As a clastic sediment rock, it contains clasts of any rock material or weathering product that is washed downstream or down current. It also contains some of the rock mineral particles like quartz or feldspar, and sometimes it can also be processed by the sedimentary, metamorphic or igneous rock fragments. It also consists some of the small particles of the quartzite, the sandstone, the limestone, granite, basalt, and also gneisses. The matrix or the ground mass is usually the one that binds the large crystals together, and that can be a mixture of sand, mud, and also the chemical cement. Okay, how does it forms? So what happens is, it is formed when sediments of rounded classes are at least 2 mm in diameter. Okay, when they accumulate together, when the particles of more than 2 mm in diameter, when they accumulate, it is being formed when the strong water current to transport and produce the rounded shape particles. Okay, so the environment of deposition will be swiftly flowing stream or beach with strong waves. Okay, so what happens is, only these conditions will be met during times of extreme flow of wave action. Okay, it is during these times that much of the sediments were moved and deposited. It was in the only in the early earth formation that you could have expected this high wave conditions, not now. Okay, so Martian conglomerate, yes, in September 2012, NASA's Mars rover, so it curiously discovered an outcrop of conglomerate exposed on the surface of the Mars also. Okay, now you cannot say that only the Earth contains conglomerate, but conglomerate is also found in the Mars also. Okay, rounded clasts with the conglomerate provide evidence that it was had a stream or a beach which moved the rocks and tumbled them into rounded pebbles. Okay, so this conglomerate is one of the most convincing evidences that water once flowed on the surface of the Mars also. This is a very huge picture of a very beautiful picture of a Martian conglomerate, which was taken by NASA's rover Curiosity. Okay, so which discovered this conglomerate, which suggests that even the Mars also contained a river or a beach at one point of time. Okay, so these are the fragments of the conglomerate. You can see how the bigger particles are being cemented with the smaller grains. Okay, you can see the larger fragments which are cemented with the smaller grains. So what is the conglomerate used for? It is used for the fossil gold placers containing gold, diamonds or other valuable minerals. So if you have visited Rajasthan, so in Rajasthan there is a small deposit of the diamond also, which is known. Okay, along the course of the Vindhyan mountains and the Rajasthan, all along this Rajasthan and the Vindhyan mountains, you can find a small belt of this conglomerate, which is known to carry diamond. Okay, so these conglomerates are mined, crushed, and also processed as a ores. Sometimes the kimberlite also may be present, which is host rock for the diamond. So a place called Kimberley in South Africa, you can see Kimberley in South Africa is one of the place where large amounts of diamond are being extracted. Kimberley in South Africa. Okay, So the first diamonds that were found in the world was in India. That was in Vajrakarur in Andhra Pradesh, very close to us. Vajrakarur in Andhra Pradesh, where it is close to Penakonda. Okay. So the first Kohinoor diamond which was found was in India from the Vajrakarur. Okay. So then later on, subsequently, it was found out in South Africa, where it was found within the Kimberley place called Kimberley. This rock was found, and that's why that name itself is being derived as a kimberlite. So coming to the final one is a laterite. So laterite, you know, jembitke. Kannadadalli ಹೇಳಬೇಕು ಅಂದ್ರೆ it is called jembitke. It is a soil and a rock type which is rich in iron and aluminium. Okay, and also it is being found in hot and wet tropical areas. Okay, all laterites are rusty red coloration because of the high iron oxide content, and also they developed by intense and prolonged weathering. Okay, so they are found now developed by the intense weathering that has been found within the parent rock. So what happens is the lateritization, it's a process, or tropical weathering is a prolonged process of chemical weathering which produces a wide variety of thickness, grade, chemistry, and ore mineralogy of the resulting soils. So coming to the uses, you can see these are the two beautiful pictures where you can see the laterite is being used as a building material. So this is picture from Cambodia, the ancient temple site, which was suggested that it is built from this laterite itself. So the ancient Cambodian temple is being built by the conglomerate, the laterite itself. So laterite is not a new one building material, but it's a as old as Cambodian history itself. You might know that the Cambodia was once part of India itself. During the time of Mahabharata, Cambodia was a part of India. Therein you can see that it was built. This is one temple which was built using your laterite rock itself. So what are the uses of the laterites? Used in agriculture, yes. Building blocks, road building, water supply, wastewater treatment. Yes, wastewater treatment is a very important concept, wherein the ancient Indians or the people of the Indus Valley civilization, if you go to Indus Valley civilization, they use this laterite for water purification purpose. Okay, they placed the blocks of the laterite one above the other, upon which they below which they laid some of the sands, the coal, the charcoal, pebbles of different sizes, and finally they placed some fine sand, after which they started to drink water, through which the water flows through all these columns. By the time water passed the final fine grained sand, the water had been purified. Okay, so it is also used in the wastewater treatment, and also it serves as a very important ore for the bauxite, iron, and the nickel deposits. So you can see these are the very beautiful pictures of the laterites which are used for the building purposes. So you can see the Nagara fort, which is present in the Hosnagara, very close to Hosnagara, that is built of the laterite itself. Many of the ancient sites, if you go towards the South Canara and the northern Karnataka, North Canara, that is Dakshina Kannada and Uttara Kannada, you can see many of the buildings are built of this laterite itself. If you go towards Sagara itself, you can find all this Keldi, all of them are being built by this laterite itself. Okay, so I'll stop my discussion here. From tomorrow I am going to continue and finish the metamorphic rocks. Okay, so if you have got any questions, you can ask me now. If you have got no questions, then drop in your USNs in the attendance, and we shall continue our discussion next class. Thank you.